This is Cambridge IGCSE for Chemistry, Paper 4, Theory Extended, from May-June 2020, Variant 2. Question number 1, give the name of the process that occurs when a gas turns into a liquid. There will just be condensation. Next question, occurs when a solid turns into a gas without first forming a liquid. There will actually just be sublimation. Give me a moment. Sublimation. 3. Is used to separate a mixture of liquids with different boiling points. Now, the keyword here is a separation technique involving a mixture of liquids with different boiling points. With that, you need to use fractional distillation. And next is used to extract aluminium from aluminium oxide. There will actually be electrolysis of alumina using cryolite, right? 5 is used to separate a mixture of amino acids. That will actually just be chromatography. All right. Question B. The symbols of the elements in period 2 of the period table are shown. For each of the following, give the symbol of an element from period 2 which matches the description. Each element may be used once, more than once, or not at all. Which element combines with hydrogen to produce ammonia? As we know that the formula for ammonia is NH3, so the element that combines with hydrogen to produce ammonia is actually just nitrogen. Next, makes up approximately 21% of clean dry air. There will actually just be oxygen gas. 3, has atoms with only 2 electrons in the outer shell. This statement actually tells you either it's a helium atom, right, or group 2 elements, right? So in the context of a period 2 group 2 element, there will actually be beryllium. All right, you can refer to your period table for this. Next question, has atoms with only 7 protons, so that will mean that it's element number 7. So element number 7 is actually just nitrogen. And next is a monoatomic gas that is actually a noble gas, which is just neon. And lastly is a soft metal stored in oil that will actually be an alkali metal, group 1 metal. So that will be lithium. All right, next question. Fluorine forms both ionic and covalent compounds. Magnesium reacts with fluorine to form the ionic compound magnesium fluoride. The electronic structures of an atom of magnesium and an atom of fluorine are shown. Complete the dot and cross diagrams to show the electronic structures of one magnesium ion and one fluoride ion. Show the charges on the ions. Now, we know that the electronic configuration of magnesium atom is 2A2, whereas for fluorine is 2,7. All right, in order to achieve stability, magnesium atom has to donate 2 electrons, whereas fluorine has to gain 1 electron. All right, with that said, what remains as the structure will be as follows. Allow me to draw this first. So the third shell electrons will be donated to fluorine, right? Leaving only 2 shells occupied with electrons. Whereas for the fluorine side, that will be just like the diagram, except you will need to place an electron that is coming from the magnesium, right? Just now from the third shell, what of the 2 electrons given to 1 fluorine atom and makes 1 fluoride atom. And with that said, the charges will turn into 2 plus and minus respectively. All right. Okay, the 3 marks are given to you based on the structure of magnesium ion, the structure of fluoride ion, and remember that you need to mention that it's actually coming from the magnesium. Hence, you need to use a cross instead of a dot. And last mark is for the charges. All right, next question. What is the formula of magnesium fluoride? Well, if you just look at the charges, they will be combining in a 1:2 ratio, so it's MgF2. Next question, magnesium fluoride does not conduct electricity when it is solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, explain why. Magnesium fluoride conducts electricity when this change is made. So we are trying to answer what can be done for this solid to conduct electricity. We were also asked to explain why. So what can be done to allow an ionic compound to conduct electricity? You will have to melt it, or you will have to dissolve it in water. All right, it's either of these two ways. And the reason is this allows the ions to be freely movable. All right, you can see moving ions or mobile ions. Okay, this allows the ions to be moving in the structure, right? That allows electrical conductivity. Next question, carbonyl fluoride is a covalent compound. The structure of a molecule of this compound is shown. Complete the dot and cross diagram to show the electron arrangement in the molecule of this compound and show the outer shell electrons only. Now, based on your periodic table, fluorine is a group 7 element, carbon is a group 4 element, and oxygen is a group 6 element, which means that their valence electrons, or should I say, the number of electrons in the outer shell are 7, 4, and 6 respectively for these three elements. All right. And then in a covalent compound, you must remember that it's made of 2 electrons. Right? So carbon, if you see that it's surrounded by 4 lines, which means that all the electrons for carbon is used in bonding. So allow me to draw for carbon's electrons so that will be like that. All right, 4 electrons. Carbon contributes 4 electrons for sharing. And for fluorine, as you can see, it is surrounded by 1 line. So that actually means that fluorine contribute 1 electron for sharing each. All right, so actually there's another 6 electrons that remain for each fluorine atom. Right? You need to draw the other 6 electrons outside of the, I would say, the bonding region. These are a lone pair of electrons. Do the same for the other fluorine atom as well. And last step is oxygen. Oxygen will also contribute 2 electrons for sharing. All right, with that, it will actually have another 4 electrons remaining. So you need to draw that as well. 1, 2, 3, 4. All right, let's check everything. Each fluorine should have 7 electrons, in which 1 is used for bonding for each of the fluorine atoms. Oxygen, it should have 6 electrons in the outer shell, and 2 of them are used in bonding. Carbon should have 4 electrons, and it uses all of them for bonding. So that's the final structure. All right, let me check the mark scheme real quick. The first mark is on the 2 single bonds, which is these 2 single bonds. The other mark is for these 2 double bonds. And then the last mark will be the non-bonding electrons, 6 for each fluorine atom, and then 4 for the oxygen atom. All right, with that, we have all 3 marks. Next question. The melting points of magnesium fluoride and carbonyl fluoride are shown. Explain, using your knowledge of structure and bonding, why magnesium fluoride has a high melting point. So, in terms of a compound having a higher melting point than the other compound, usually we relate it to bonding, where the bonding is stronger. All right? So, we can just, I would say, allow me to draw a table, right? So they see what's the correlation. All right, first of all, our understanding of magnesium fluoride, it's composed of a metallic element and non-metallic element, which means that it's actually an ionic compound. Right? In ionic compound, there's actually ionic bonding that exists between oppositely charged ions, and the strength of ionic bonding is actually pretty strong, which makes it, in general, a higher melting point than most compounds. Meanwhile, comparing it to the covalent compound, which is carbonyl fluoride, is actually a covalent compound because it's composed of non-metallic elements. And in covalent compound, it has covalent bonding. However, remember that it's not used for melting. All right, it's a misconception that covalent bond in a simple covalent molecule is broken. All right, it will not be broken during melting. Instead, it's actually the weak intermolecular forces that are getting broken here. As you can see, the strength of ionic bonding in the magnesium fluoride is stronger than the weak intermolecular forces in the covalent compound. Hence, the melting point is lower for the covalent compound as compared to the ionic compound. All right. In exam, of course, you can't draw a table. I'm just drawing the table to show how you compare these two compounds. So how you can write this is that you just say that the ionic bonding, right, or is stronger than the weak intermolecular forces in the covalent compound, which requires more heat, right? Requires more heat to break the bonds. Or should I say breaking the force of attraction compared to the weak intermolecular forces. Hence, it has a higher melting point than the carbonyl fluoride. All right, so make a comparison out of it, and you can actually, I just realized that this question actually separate them. That's an interesting thing to do. Most of the years they actually combine together. Okay, I don't see that. Okay, so let's just restructure our whole idea, which let me just move this to the bottom, right? Okay, so how do we write 2 marks? By saying that in the magnesium fluoride, ionic bonding exists in magnesium fluoride where it is strong in nature and requires more heat to break the force of attraction, hence the melting point is high. And then on the other hand, we can talk about carbonyl fluoride. It has weak intermolecular forces of attraction, which requires less heat to overcome, hence the melting point is lower. All right. It's an interesting way to do this year's question because they choose to separate them, but no worries, the concept should be the same. You just need to use the bonding to explain your answer. All right. For magnesium fluoride, it's ionic bonding. For carbonyl fluoride, it's weak intermolecular forces. And then you just talk about which one requires, sorry, should I say, you separate them in terms of just trying to tell that it requires more heat to break the ionic bonding in magnesium fluoride. And then for 2, you just say that you require less heat to overcome the weak intermolecular forces. Right? That should be able to get you all 4 marks. Right? Okay. Moving on to the next question. Sulfuric acid is made from sulfur in a 4-stage process. Sulfur is converted into sulfur dioxide. Sulfur dioxide is converted into sulfur trioxide. And sulfur trioxide is converted into oleum. And oleum is converted to sulfuric acid. How is sulfur converted to sulfur dioxide in stage 1? It's just simple burning to allow oxidation. So burning in air, heat in air. All right. Next question. Describe how sulfur dioxide is converted to sulfur trioxide in stage 2. Your answer should include an equation for the reaction, the temperature used, and the name of the catalyst used. So pretty much this is actually your contact process. So the equation is sulfur dioxide reacting with oxygen to form sulfur trioxide and balance them. Next, the temperature used is 450 degrees Celsius. Make sure you mention in your unit. And also the name of the catalyst used is actually vanadium 5 oxide. And remember to mention the Roman numeral 5. Right? Next, the reaction in stage 2 can reach equilibrium. What is meant by the term equilibrium? Equilibrium means that the rate of the forward reaction is equal to the rate of the reverse reaction, where the concentration of the reactant and the products remains unchanged, or should I say remains constant. All right, 2 marks. Next, sulfur trioxide is converted into oleum in stage 3. What is sulfur trioxide reacted with to convert it into oleum? There will actually just be sulfuric acid. In fact, concentrated sulfuric acid. Right? Next question. Oleum is then converted into sulfuric acid in stage 4. Write a chemical equation for the conversion of oleum into sulfuric acid. So how we do it is by adding it with water. So oleum takes in water, and that allows formation of sulfuric acid, and then you balance the equation. That's the final answer. 2 marks. Next question. When copper is reacted with hot concentrated sulfuric acid, sulfur dioxide gas is formed. Balance the chemical equation for this reaction. All right, so let's just try to balance them. Copper has equal amounts for both sides. That's done. Sulfate on the right-hand side, there's 1 sulfate and 1 sulfur. Sorry, or should I say, in total, there are 2 sulfur atoms, which means that on the reactant side, this coefficient must be 2, because the number of sulfur on the right is already predetermined, it's already set as 2, so you should put a 2 here, and the rest is just you try to balance it accordingly. So that will be 2 more. Let me check the answer real quick. Copper on both sides 1:1 ratio, sulfur 2:2 ratio, oxygen will be 8:8 ratio, and hydrogen will be 4:4 ratio. That is done. All right, next question. Sulfur dioxide is a reducing agent. Give the color change that occurs when excess sulfur dioxide is bubbled into acidic aqueous potassium manganate 7. Now, the starting color of the solution, which is acidified potassium manganate 7, is actually purple. And when this reagent acts as an oxidizing agent, which means that it gets reduced, it will turn into a colorless solution. All right? So, next question. When sulfuric acid reacts with ammonia, the salt produces ammonium sulfate. Write the chemical equation for this reaction. Let's just do that anyway. Sulfuric acid is H2SO4, ammonia is NH3, and ammonium sulfate is NH4 2SO4. So with that said, let's just put them together. That should be your first mark. And your second mark should be just balancing. Sulfate on both sides are equal. And I need 2 ammonia molecules to make 2 ammonium molecules. That should be balanced. All right, the first mark should be on the chemical formula, and the second mark should be on the coefficients. Right, next question. Barium sulfate is an insoluble salt. Barium sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of barium sulfate. So we're trying to do precipitation here. So in order to do precipitation, or should I say preparation of an insoluble salt, we need 2 soluble salt solutions, which one of them is given, right? So we need another aqueous solution that contains the ion barium. Because you see, the first solution given to you already contains sulfate. So first half of the recipe, we already have the materials. We just need the barium ion. So we need a soluble salt that contains barium. Example will be barium nitrate. Right, nitrate salts are all soluble. And next, write ionic equation for this precipitation reaction and include state symbols. So it will be barium ion in its aqueous form reacting with sulfate ions in its aqueous form, forming barium sulfate in its solid form. So that's the answer, including the state symbols. Next question. Oxygen is produced by the decomposition of hydrogen peroxide. Manganese 4 oxide is the catalyst for this reaction. What is meant by the term catalyst? It's a substance that increases the rate of reaction by lowering activation energy, or you can say that it remains chemically unchanged at the end of the reaction. Or you can also talk about how it allows lowering of activation energy by providing an alternative pathway for the reaction to occur. Right? So that's how you explain a catalyst. Next, a student measures the volume of oxygen produced at regular time intervals using the apparatus shown. Large lumps of manganese 4 oxide are used. A graph of the results is shown. What happens to the rate of this reaction as time increases? And in your answer, explain why the rate changes this way. Now, the point of the question is about rate of the reaction as time increases. Now, be very careful of this one. Your y-axis in the diagram, in the graph, is not rate, you see. It's actually product formation. So we have to not just observe the y-axis, but actually in order to observe rate, we must look at the gradient of the graph, not the y-axis directly. So we see the gradient actually becomes smaller and smaller as time progresses, which means that rate decreases as time increases. Right? That should be our first point. Now, why? Why is that the case? Now, the reason is because your amount of reactants is getting used up, right, as reaction progresses. That actually causes the concentration of reactants decrease over time. All right? Or you can just, how do we further explain this? Well, define concentration of reactants. So that will be just of less reactant particles per unit volume over time, which leads to less collision rate between the reactant particles and also lead to less successive collision rate, which ultimately leads to, sorry, let me use the word frequency, because not to be confused with the rate of reaction. I will suggest students to use the word frequency so that you're not confused with the rate. So that finally leads to rate of reaction decreases over time. All right. So first, this is your first mark. All right. Basically, basically providing an answer to the first question. Then the rest of the 3 marks will be based on your explanation, which is based on the concentration of reactants decrease over time. Then you further define it, you can say that, oh, concentration of reactants decrease over time essentially means that there are less reactant particles that can react with each other per unit volume over time. And that actually leads to less collision frequency and ultimately lead to less successive collision frequency. Hence, rate of reaction decreases over time. Right? Yes, and finally, all the reactants are used up. The limiting reactant used up. All limiting you can also further establish this. All limiting reactant used up at the end of reaction. At the end of the reaction. Hence, reaction stops. Right? No more limiting reactant. The reactant that is limiting is pretty much limiting the reaction, and no more reaction is happening. All right, next question. The experiment is repeated using the same mass of manganese 4 oxide. Powdered manganese 4 oxide is used instead of large lumps. All other conditions stay the same. Sketch a graph on the axis in B to show how the volume of oxygen changes with time. Well, this manganese 4 oxide is actually just a catalyst. Right? Ultimately, it is not a reactant. Which means that you will not form more products. So the maximum Y value of the reaction should be the same as of this particular amount. However, because you're using powdered form, which means that the reactants have, I would say that they are in contact with the catalyst more, right? With a greater, exposed to a greater surface area, so that allows the reaction rate to be carried out faster. All right, so the marks are given based on 2 parts. The first part of the graph, which is a steeper gradient, and the second part of the graph, which is referring to the same product volume form. Right, next question. In terms of particles, explain what happens to the rate of this reaction when the temperature is increased. Well, when temperature increases, the kinetic energy of particles increases, which makes them move faster. All right, then you can talk about that leads to greater collision frequency as of they start to move faster, which means they collide more. And in turn, it leads to greater successive collision, right? Or you can just say that there will be a greater fraction of particles with possessing activation energy. All right, they finally lead to greater successive collision. All right. Now, the equation for the decomposition of hydrogen peroxide is shown. 25 cm³ of aqueous hydrogen peroxide forms 48 cubic centimeters of oxygen at room temperature and pressure. Calculate the concentration of aqueous hydrogen peroxide at the start of the experiment using the following steps. Calculate the number of moles of oxygen formed. Now, we are given the volume of oxygen, which is a gas. All right, we know that in a gas, pretty much 1 mole occupies 24 cubic decimeters of volume. All right, this is a special characteristic for gases. So with that said, we're trying to find for 48 cubic centimeters, how many moles is that? So let's say we are trying to take 48 by taking the volume divided by the molar volume, and that gives us that gives us the number of moles. All right, but make sure that you convert this into decimeter cube. All right, so allow me to use the calculator for this question. That gives me 0.002 moles. All right, next, deduce the number of moles of hydrogen peroxide that decompose. So based on our equation, our recipe, it tells us that the theoretical mole ratio is the 2:1 ratio. All right, 2:1 ratio for hydrogen peroxide and oxygen. So if you mean that it is 0.001. Wait, no. Oh yeah, wait, give me a moment. Let me think. No. I was a little bit rushing. Give me a moment. So this one 0.002, that will mean that it's 0.004. Right? Now, next, calculate the concentration of hydrogen peroxide in mole per dm cube. We are given the moles. Sorry, or should I say we found out the moles of hydrogen peroxide, which is 0.004. We found out the volume of the hydrogen peroxide used is 25 cubic centimeters, which essentially is 0.025 decimeter cube. And we can use these two values to find out concentration. And hence you just take 0.004 divided by 0.025. And that allows us to find the answer is 0.16. All right, next question. Oxygen can also be produced by the decomposition of potassium chloride 5. The only products of this decomposition are potassium chloride and oxygen. Write the chemical equation for this decomposition. So we see that potassium chloride 5 decomposes into potassium chloride and oxygen. So it's KCl and O2. And we need to balance it. Right? The first mark is on this. The second mark is on balancing. So I believe it's a 2, 2, 3. 2 potassium on the left and the right. 2 chlorine on the left and the right. And 6 oxygen in total for the left and the right. Right, next question. Electrolysis of concentrated aqueous sodium chloride using inert electrodes form chlorine, hydrogen, and sodium hydroxide. What is meant by the term electrolysis? So it's electro refers to by the passage of electric current, and lysis means breakdown, or should I say a proper term that we use is decomposition. And what is decomposed in electrolysis of ionic compounds? In molten or aqueous state. All right. Now, next question. Name a substance that can be used as inert electrodes. They will either be platinum or graphite. Next, write an ionic half equation for the formation of hydrogen during this electrolysis. So hydrogen came from the hydrogen ions in the aqueous solution, and hydrogen ions receive electrons to form hydrogen gas. And you just need to balance it by putting 2 and 2, as of 2 hydrogen ions receive electron each, making a hydrogen molecule. Next question, give the formulae of the 4 ions present in concentrated aqueous sodium chloride. So sodium chloride tells you that it has Na plus and Cl minus. Whereas for aqueous, it means that there's hydrogen ions and hydroxide ions. Next question. Explain how sodium hydroxide is formed during this electrolysis. Well, because you see, in the reaction, hydrogen and chlorine is formed, which means that chloride ions and hydrogen ions are discharged in this fraction. All right, and sodium and hydroxide ions, they remain in the solution, making sodium hydroxide. Now, next question. Propane reacts with chlorine in a photochemical reaction as shown. What type of reaction is this? This is substitution. Not to be confused with displacement. All right, displacement is a different reaction. If we're talking about alkanes, right, that it gets substituted by halogens, that's actually a substitution reaction. What condition is needed? Ultraviolet light. Right? You can't just give me light, right? You have to give me UV light. Right? It doesn't work under normal light. Next, draw two structural isomers of the compound with the formula C3H7Cl. Show all of the atoms and all of the bonds. Now, I'm drawing a 3-carbon compound. Actually, it's a haloalkane. If you're interested, you can search on that. And I need to draw 7 hydrogen atoms. So I can make the chlorine atom at the second carbon atom, or I can make the chlorine atom on the first carbon atom. So those are the two isomers of this particular haloalkane. It's actually chloroalkane. One is 2-chloroalkane and the other one is 1-chloroalkane. Right? Next question. Propene reacts with chlorine in an addition reaction as shown. State why is this an addition reaction? So because it only forms one product. When these two molecules join, when two reactant molecules join. Right? Next question. The structures of the reactants and products in this reaction are shown. Some bond energies are shown in the table. Calculate the energy change for the reaction between propene and chlorine using the following steps. Calculate the energy needed to break the bonds, calculate the energy released when bonds are formed, and calculate the energy change for the reaction between propene and chlorine. So let's just establish first. I need to break from this first molecule. I need to break 1, 2, 3, 4, 5, 6, 7 CH bonds. I need to break 1 C double bond C. And this one I need to break 1 chlorine bond, which is 242. Right, let's just find out the bond breaking first, which is 7 multiplied by 413 plus 612 plus 242. Wait a minute. Actually, you don't have to break everything. You don't have to break everything. You just need to break the carbon-carbon double bond and also the chlorine bond, because this is a addition reaction. So actually, the other bonds are not broken. You just need to find this one. My bad. You just need to find this and this. So we can forget about the other 7 CH bonds. We just need to find 612 plus 242, which makes it 854. All right, next, calculate the energy released when bonds are formed. So I'm forming 2 bonds here. Wait, 3 new bonds here. Yes, I'm forming 3 new bonds here. So I need 347 and 2 CCl bonds, which is 339 times 2. 1025. And hence the net energy change is because the energy release is more, so I'm going to get a negative symbol. So I'm going to take the bond breaking energy, take away, or should I say minus the bond formation energy. That gives me final answer, negative 171. Yep, negative 171. Right, that's the final answer. Next question, there are 3 functional groups in compound A. Name the homologous series of compounds that contain the following structures. So the first one is a carbon-carbon double bond that occurs in alkenes. Then the next one is hydroxyl group that's actually occurring in alcohols. And the last one is a carboxyl group that occurs in carboxylic acids. Right, next question. How would you observe when compound A is added to aqueous bromine? So aqueous bromine reacts with unsaturated hydrocarbon, which is alkenes. So you will see that bromine, because it reacts with the alkene, it will turn colorless. From brown to colorless. And for aqueous sodium carbonate, because it's a carbonate salt, it reacts with acid, which is the carboxylic acid part, and that actually forms carbon dioxide. So what do you observe? You cannot mention carbon dioxide because you can't see carbon dioxide, but what you can see is effervescence. Right? Next question. Compound A can be used as a single monomer to produce 2 different polymers. Draw one repeating unit of the addition polymer formed from compound A. So to draw the repeating unit, all we need to do is just open a double bond, right? Quote unquote, open a double bond. So you can just copy and paste the entire thing first. Now you just need to open the double bond and make it into 2 single bonds on the edges. Right, so that's the repeating unit. And what type of condensation polymer is formed from compound A? Well, because this is a addition polymer. So wait, pause. This is for one is for addition polymer, but the second question is on condensation polymer. So you want to make condensation polymer. You will form because it's an alcohol and a carboxylic acid. Sorry, there's a hydroxyl group and also a carboxyl group. It will mean that it will form a polyester, because we know that carboxyl group and hydroxyl group react together to form an ester. Right, so it will form a polyester instead. And I think that's the end of the paper. Yes, that is the end of the paper. Thank you for watching, and I'll see you in the next one. Subscribe this video subscribe to this channel if you like more discussions, and I'll see you in the next one. Bye.